It began with a small blip on a telescope in Chile, a speck of light moving where it shouldn't. As of July 1, 2025, astronomers with the Atlas survey caught sight of something extraordinary. An interstellar visitor officially named C2025N1 Atlas, or more evocatively, 3I Atlas, the third confirmed extraterrestrial object in our solar system, had entered our cosmic neighborhood. Unlike anything born in our backyard among the stars, this object follows a path so bizarre, so statistically improbable that it has left scientists buzzing with questions. Is it just a comet? A chunk of ice and dust thrown from a faraway star? Or could it be something more? A glimmer of something engineered? A whisper from the void? The discovery of 3 Atlas is not just another space rock sighting. It's a puzzle that challenges our understanding of all things. Today we're diving deep into its story. From its bizarre trajectory to the tantalizing possibility of a signal that has everyone talking. Buckle up because this cosmic mystery is about to take us on a wild ride. If you're as fascinated by the unknown as I am, hit that like button and subscribe for more journeys into the universe. Let's start with the basics. 3 Atlas was spotted by the Asteroid Terrestrial Impact Last Alert System, ATLAS, a system of telescopes designed to catch objects that could put Earth in danger. Located in Cerro Hurtado, Chile, ATLAS is a cosmic watchdog scanning the skies for anything out of the ordinary. On that fateful July day, it flagged a faint point of light moving at 58 kilometers per second, about 670 million kilometers away from the Sun, approximately Jupiter's orbit. That's 4.5 astronomical units AU for those keeping score, with $1 Australian being the distance between Earth and the Sun. What made this object stand out wasn't just its speed but its path. Most comets and asteroids in our solar system follow elliptical orbits, looping back to the Sun like loyal pets, not 3 Atlas. Its trajectory is hyperbolic. A one-way ticket through our system, never to return. This marks it as a visitor from another star, perhaps born light years away. The International Astronomical Union's Minor Planet Center confirmed it, assigning the 3I prefix, following in the footsteps of 1 Alma in 2017 and 2I Borisov in 2019. Only 3 such objects have ever been confirmed. Each one a rare gift from the cosmos, offering a glimpse into the physics and chemistry of faraway worlds. So why is 3 Atlas so unique? To begin with, it is not merely passing through. It's putting on a show. Early images from the Hubble Space Telescope revealed a fuzzy halo around the object. A coma of gas and dust stretching up to 15,000 kilometers across. This is classic comet behavior where sunlight heats the icy nucleus, causing it to sublimate and release clouds of material. Estimates suggest the nucleus is small, likely under a kilometer wide, though some models put it as large as 5.6 kilometers. That's tiny compared to local comets like Hale-Bopp. But as an interstellar visitor, its activity is significant. The coma's presence was a surprise since not every interstellar object shows such activity. Oumuamua, for example, was stubbornly inert with no signs of outgassing, which fueled speculation about its nature. 3I Atlas, by contrast, announced itself as a comet from the start, its icy heart reacting to the Sun's heat. But it's not just the comet's appearance that's turning heads. It's where it's going and how. The inclination of its orbit is jaw-dropping, 175, meaning it's moving almost perfectly retrograde opposite the planet's motion and skimming just 5 off the ecliptic plane, the imaginary disk where our planets revolve. Quantitatively, the odds of an interstellar object aligning so closely with our solar system's plane are about 0.2%, 2 in a 000. That's already a cosmic coincidence. But it gets stranger. As 3I Atlas barrels through, it's set to pass unusually close to 3 major planets, Venus, Mars and Jupiter. According to calculations by scientists at Harvard, Caltech and JPL, the likelihood of a triple flyby like this happening by chance is 0.05% to 1 in 20,000. To put that into context, it's like tossing a dart from across the galaxy and hitting a bullseye the size of a pinhead. Beginning in October 2025, it will skim within 30 million kilometers of Mars, a cosmic hair's breadth with similarly tight approaches to Venus and Jupiter. Each encounter is timed with eerie precision, making the path of this object look less like random wandering and more like a carefully choreographed dance. Why is this important? Because a trajectory this precise raises questions science can't easily dismiss. Most objects from other stars crash into our system at strange angles, their routes chaotic and unconnected to our planets. 3I Atlas, however, is practically hugging the ecliptic, moving in a way that makes the most of its planetary interactions. Harvard astronomer Avi Lowe, never one to shy away from bold ideas, has pointed out that if you wanted to design a probe to study multiple planets while staying hard to spot, this is the path you'd pick. The object's perihelion, its closest approach to the Sun, occurs on the far side from Earth, obscured by the Sun's glare, making detailed observations during this critical phase nearly impossible. It's a natural blind spot, ideal perhaps for someone or something attempting to slip through unnoticed. Now let's be clear. There's no evidence yet that 3I Atlas is anything but a natural comet, but its path is so statistically unlikely that it's forcing scientists to at least entertain the possibility of something more. Lowe's team even ran simulations suggesting a reverse orbit maneuver at perihelion could allow it to use the Sun's gravity to slow down, potentially dropping into orbit or deploying smaller devices toward nearby planets. Although unlikely, the math checks out. Now, let's talk about that signal, the one that has everyone from astronomers to Space Force analysts on edge. The United States Space Force operates a network called Space Fence, a radar array on Kwajalein Atoll that can detect objects as small as a marble in low Earth orbit. It's part of a broader system called the Space Surveillance Network designed to track everything from satellites to space debris. Space Fence is so sensitive it can spot centimeter-sized fragments thousands of kilometers away, and it scans the sky constantly, recording thousands of objects daily. If something like 3I Atlas or a signal tied to it entered our system, Space Fence would likely notice. The Deep Space Advanced Radar Capability (DARC) is another piece of the puzzle, with arrays in Australia, the UK, and the US designed to monitor the geosynchronous belt where communication satellites live. In total, these systems make a digital catch-all net for anything unusual. Space Force's mission, called Space Domain Awareness, isn't just about tracking rocks. It's about identifying anomalies, including potential signals. While no declassified records confirm a transmission from 3I Atlas, the rumor of a signal, possibly a narrowband radio emission, has sparked intense speculation. If you're wondering what Space Force might know, hit that subscribe button to stay updated as this story unfolds. Catching a signal from space isn't as simple as tuning a radio. Astronomers use a rigorous process to separate cosmic whispers from the universe's background noise. The search frequently focuses on the water-hole band, a quiet slice of the radio spectrum between 1420 and 1666 MHz where interference is minimal. A candidate signal must pass several tests. First, it needs to show Doppler drift, a change in frequency consistent with the movement of a celestial object like the shifting pitch of a passing car. The famous WOW signal of 1977 passed this test, showing a drift consistent with a cosmic source, but it never repeated, which is another key hurdle. A true signal should reappear when telescopes point back at the same spot or show up in data from other observatories. Astronomers also use an on-off test, pointing the telescope at the target, then at empty sky. If the signal vanishes when the telescope moves away, it's a good sign it's not local interference like a satellite or a microwave oven. Machine learning now helps sift through millions of signals, flagging only those that survive every filter. Even then, most candidates turn out to be false positives. A prime example is the BLC-1 signal in 2020. Detected by the Parkes telescope while scanning Proxima Centauri, BLC-1 looked promising, persistent, drifting, and only present when pointed at the star. But after months of analysis, it was traced to human-made interference, a mix of electronic signals mimicking a cosmic source. This is why skepticism is the default in the search for extraterrestrial intelligence, or SETI. Avi Lowe's work adds another layer to this story. In August 2025, he released the Lowe Scale, a system to classify interstellar objects based on how much they deviate from expected natural behavior. Rated from 0 to 10, a level 4 object like Oumuamua and now 3I Atlas shows multiple anomalies that resist easy explanation. For 3I Atlas, these include the triple planetary flyby, the precise retrograde orbit, and its alignment with the ecliptic. These traits don't scream alien technology, but they do raise questions that can't be brushed off. Lowe argues that if a probe from another civilization wanted to study our system, it might choose a path like this, maximizing data collection while minimizing detection. The dark forest theory, a concept from astrobiology, suggests advanced civilizations might stay quiet to avoid threats, making stealthy probes a logical choice. While most astronomers lean toward natural explanations, the level 4 rating keeps 3I Atlas in the spotlight. A cosmic question mark requiring additional data. Take a step back and examine the human side of this story. The discovery of 3I Atlas wasn't just a triumph of technology. It was a global effort. Amateur astronomers helped spot the object in prediscovery images from mid-June just before it was lost in the crowded star fields near the galactic center. The Zwicky Transient Facility and other surveys pieced together its path while NASA and JPL confirmed its interstellar nature. This kind of collaboration shows how far we've come since the days of lone astronomers peering through telescopes. Today it's a network of professionals and enthusiasts, algorithms and observatories, all working together to catch the universe's fleeting visitors. Imagine being one of those amateurs using your laptop to scan images and realizing you've helped discover something from another star. It's a reminder that space exploration isn't just for rocket scientists. It's for anyone curious enough to look up. So, where does 3I Atlas leave us? It's a comet, yes, but one with a course that defies the odds. Its close encounters with Venus, Mars, and Jupiter combined with its retrograde orbit make it a statistical unicorn. The signal rumor, while unconfirmed, adds a layer of intrigue. Decades of SETI research remind us to tread carefully. Telescopes worldwide are currently tracking 3I Atlas, capturing every detail before it fades into the interstellar void. The facts we have: a 175-degree inclination, a speed of 58 kilometers per second, and a nucleus estimated between 0.3 and 5.6 kilometers, paint a picture of a rare but natural object, at least for now. Yet the questions linger. Why this route? Why these flybys? And if there was a signal, what would it mean? The answers may lie in the next generation of observatories, or they may stay just out of reach. A cosmic tease from a universe where secrets are treasured. One thing is certain. 3I Atlas reminds us that the universe is vast, strange, and full of possibilities. If this journey into the unknown has sparked your curiosity, give this video a thumbs up, share it with a fellow space nerd, and let me know in the comments. Do you believe 3I Atlas could be something more than just a comet?